Welcome back, everybody, to Spring One. And I am so excited about our next talk. Sometimes people think, you're in a beginner track and but I've been coding for so many years, there's nothing really new to learn. Well, today I've been learning so much. And in this next talk, I'm going to be learning so much more, and I'm very excited. We're going to be learning RSocket using RSC. And our presenter today is Toshiaki Maki. Toshiaki, take it away.
Hello everyone, I'm Toshiaki Maki. I work at VMware as a staff cloud native architect based in Tokyo. It's midnight here, but I'm excited to present at Spring One. Today, I will talk about running RSocket using RSC. In this session, I will first give a brief introduction to RSocket. Then I will demonstrate some features of RSocket using a CLI called RSC. You can get today's slide and source code from the URL described on the slides. This slide will be public after the session. First of all, I would like to introduce RSocket. RSocket is a binary protocol over TCP or WebSocket or UDP, unlike the text protocol HTTP. It is multiplexed and bidirectional. It's located in the fifth or sixth layer in your familiar OSI model, or in the application layer in the TCP IP model. It has four interaction models: request response, request stream, request channel, and fire and forget. I will explain these later. One of the major features is that RSocket supports reactive stream semantics. That means that backpressure is supported within the specification. RSocket is currently being developed as a project of Reactive Foundation. When you hear this RSocket overview, you may be wondering what makes it different from gRPC. It's actually one of the FAQs. This figure shows the difference between RSocket and gRPC. As you can see, RSocket and gRPC are on different layers of comparison. It's not really an apple-to-apple comparison. RSocket is transport agnostic, message format agnostic, and programming model agnostic. On the other hand, gRPC is an RPC framework that uses protocol buffer over HTTP2. Technically, you can also implement RPC with protocol buffers using RSocket. However, if you want to use RPC, you may want to use a widely adapted gRPC. If we want to implement web applications on WebSocket for performance reasons, you may want to use RSocket as a higher-level application protocol. It is also possible to implement RSocket over new protocols like QUIC or HTTP3. Spring Framework has supported RSocket since version 5.2 and provides a messaging style programming model. You can also use a functional style programming model using Spring Cloud Function. The source code on the left side is a server-side example. I'm assuming the audience has used Spring MVC or Spring WebFlux, and you'll see that the source code looks very similar to Spring MVC's controller. Use message mapping for RSocket instead of a get mapping or a post mapping for HTTP, and use a payload instead of a request body. This leverages the existing Spring messaging annotations. On the client side, RSocket requester is provided, which is an RSocket variant of Spring MVC's REST template or Spring WebFlux web client. The source code on the right side is an example using RSocket requester that calls the API on the left side. RSocket requester is very useful client API, but I'm not happy to write client code every time I try server API. You can use RSC CLI for RSocket, like using curl when trying a REST controller endpoint in Spring MVC instead of a REST template. RSC is an RSocket CLI developed by me. It is compiled by GraalVM as a native image and starts up instantly. Available for Mac, Linux, and Windows. For Mac and Linux, you can install it with Blue install. This session makes heavy use of RSC for demonstrations. Now, as shown at the beginning, I will explain about the four interaction models. Request response is the most straightforward model. it sends one message and receives a response, much like HTTP. Unlike HTTP, RSocket connection is persistent. Instead of destroying a connection each time you send a message, use the connection you created first and continue sending and receiving message using that connection. Request stream is a model that sends one message and receives a stream consisting of multiple messages as a response. Request channel is a model like a chat application that sends and receives a stream of messages. Fire and forget is a one-way interaction that sends message but does not receive a response. This is useful when sending the message itself is important and you want better performance. Now it's time for a demo. Let's use RSC to show 4 interaction models. Let me play the pre-recorded video for the demos. Here is an example of a very simple RSocket API. As you can see, it's very similar to Spring MVC or Spring Web Proxy Controller. It uses Reactor API. Mono represents 0 or 1 element stream, and proxy represents a multi-element stream. This is for the request response model that returns mono. In this case, the uppercase of the input text will be returned. This is for the request stream model that returns proxy, and it's repeating the input text. So this will be an infinite stream. This is for the request channel model that returns proxy as well, and it also takes proxy as an input. This is for the fire and forget model that returns mono void. That means 0 element stream. This application uses TCP as a transport layer, and the server port is 7000. To access this API, you can use RSocket request client like this. You can specify route and data like this. Equivalent access to this API can be done using RSC. We can specify route and data using this option. Look, the response is returned. You can use debug option to see the RSocket protocol. Like this. It's very helpful debugging. For request stream, you can specify stream option. This will return an infinite stream, so use take option to stop getting data on the client side. Let's take 10 elements, please. In this case, more data is actually being generated on the server side. Look, more than 1,000 data are generated. How to prevent the wasteful generation will be explained later. For request channel, specify channel option. And if you pass a hyphen to the data option, sending data from standard input. In this case, the inputted data will be returned one by one in uppercase letters. So RSocket string 1, hello, goodbye. Yes. For fire and forget, use FNF option. There will be no response, and it's hard to see what is happening. So use debug option to see what it sent. This you can see fire and forget is actually used as an interaction model. All right, let's go back to the slides. From now on, I will introduce some of the features of RSocket with demonstrations. I'll show you 5 features: backpressure, session resumption, client responder, authentication, and tracing. The first feature is backpressure. RSocket supports reactive stream semantics in the specification. This means that when sending a request, you can specify how many messages you want the server to generate and control the flow rate. In the example shown in this figure, the client is asking the server, give me 3 data, then give me 2 data via request n. This is a very powerful feature. This prevents the client from being overwhelmed by the server over providing messages. And it also prevents the server from overloading by producing too many messages. Let me show you a demo of backpressure. In the previous request stream demo, we saw that a lot of data were generated on the server side to get 10 data. Let's try it again. More than 1,000 data were generated. This situation will get even worse if the client-side processing is slow. Let's emulate this situation using delay element option. More than 60,000 data were generated to get only 10 data on the client side. You can mitigate this situation using backpressure. With limit rate option, you can specify the upper limit of the number of data generated by one request on the server side. You can see the amount of data generated by server side dramatically smaller than previous example. Let's see how the number of data is specified in the RSocket protocol using debug option. You can see it sends requests n3 every time it receives 3 data. The server also processes data 3 by 3. You can adjust the number of requests depending on how busy the client is. If the limit rate is 1, the data will be processed one by one on the server side. Yes. This flow control is a powerful mechanism that RSocket has. Next topic is session resumption. Session resumption is a mechanism to reconnect and restart a stream when communication is interrupted in the middle of the stream. It is useful for systems used in environments with unstable network. For example, as shown in this figure, suppose that the elements from A to E are generated and the communication is interrupted while A and B are being transmitted. If session resumption is enabled, the transmission of data after C will be resumed when the connection is restored. Since backpressure works, no new data will be generated on the server side while the connection is interrupted. Data generation will also be resumed when connection is restored. Let's emulate unstable communication here. A simple proxy is prepared by using socat command before the RSocket server. RSC sends a request to this proxy, and I stop and restart the proxy to mimic the unstable communication. Let's see the demo. Start the proxy that listens on the port 7002 in front of the RSocket server. Using resume option, you can pass the maximum time for a client to keep trying to reconnect. Now 60 seconds. The data is being generated. Then stop the proxy. You can see the server stopped generating data and restart the proxy. Now the stream has been resumed successfully. Okay, next I'll talk about client responder. This is also one of the very interesting features of RSocket. In the traditional client-server model like HTTP, it is obvious that the client sends a request and the server returns a response. Let's call here the side that sends a request requester and the side that returns the response responder. In the example shown so far, the client was the requester and the server was the responder. Interestingly, RSocket allows the server to be a requester and the client to be a responder once the connection is established. The server-side requester can send a request to the client at any time. For example, a server can collect client-side metrics. This feature is also available when a server outside the firewall wants to send a request to a client inside the firewall. Now let's demonstrate the client responder. In this demo, the server sends a string to the client and the client returns a response to the server with hello. This is a common hello example with the client and server opposite. The server endpoint can get the RSocket requester to the client. Using this requester, the server can send the server can call the client at any time. In this demo, server sends the data from standard input on the server side. The client responder feature in RSC is work in progress. I'll show you the experiment feature. With responder option, you can pass the program that implements interaction models in JavaScript. This is pretty simple example that implements request response on the client side. It returns the response with hello to the request. Let's try it out. Now, server waits for the input. Enter Spring. You can see the hello Spring is returned from the client. It's very interesting feature. Again, this feature is work in progress and is not released yet. If you want to try it, feel free to ask me. Next, I will explain about authentication. RSocket supports simple authentication and bearer token authentication as authentication methods. Simple authentication sends a username and password like HTTP basic authentication. And bearer token authentication sends a token like JSON Web Token. As Spring users may have noticed, Spring Security supports these methods for RSocket. RSC also supports these authentication methods, so I will demonstrate it now. First, let's take a look at the configuration. Simple authentication is required for the hello route, and other routes are permitted. Authenticated users can be obtained with authentication principal annotation. Let's access the hello route without authentication. Access is denied as expected. Next, let's pass the correct username and password to auth simple option. The response is returned successfully. Then use wrong password. Invalid credential is returned. Bearer token authentication is also available if you want. Finally, I will talk about tracing. RSocket supports B3 as a distributed tracing format. That is, you can send to a Zipkin compatible server how long each interaction model took, and you can propagate the trace to the backend services. Again, Spring users may have guessed Spring Cloud Truth supports RSocket tracing from the latest version. This will also be demonstrated with RSC. The backend service is now running on port 7001 with a different profile SVC2. Both front end and backend send traces to Zipkin. Front service calls the backend 3 times using RSocket requester. Each send hello, world, and tracing. The processing time is 100, 300, and 200 milliseconds. Let's call the API. The response is in the order of hello, tracing, and world due to the difference in processing time. Check the trace with Zipkin. You can see at a glance where the slowest part is. This one. Check. You can see interesting RSC can also initiate the tracing using trace option. You can check the time difference between the client and server. Yes. Now, let's start the session. I first talk about a brief introduction to RSocket and Spring support. I then demonstrated some RSocket features using the RSC CLI. In addition to this session, Spring 1 has several practical sessions on RSocket. If you are interested, please check the recordings. Thanks for your attention and enjoy the rest of the conference. Bye.
Toshiaki, thank you so much for that presentation. I had a chance to really kind of get an eye for what RSC can do for us as a developer. So thank you for your presentation. And folks, please join him in the Zoom session. And you should be able to see that in your Slack. If you go to Slack, you'll have a link to your Zoom session. Toshiaki will join you there. Feel free to ask your questions on anything dealing with RSocket, RSC, and he will be there to field those for you. Up next is live coding Spring data queries to the end of the persistence universe, brought to us by Greg Turnquist, and that will start right at 11:35 a.m. Eastern Standard Time. I look forward to seeing you then.